Okay, dear students, after a short break, then well, ready to continue. Remember, just before the break, finally, I focused your attention to the most valuable projection. It is the development. Well, instead of having the final form of the object, okay, just provided info is on the side views, okay, but you have the development. Then see, well, creating this model, remind you, well, first I created this part, and then applying flange process had this banded portion, and well, such intermediate banded part, just I had a sketch and then apply phase process, and for empty spaces cutting process, embosses, etc. But if it is the case that, well, you have the development only with such valuable technical notes, then, well, see how the sheet metal work is created. Yes, say that, answer the question, selected sheet metal work template, clicked on create, and then start sketching stage. Sketch. And then, well, I'm going to, well, skip the sizing stage here. Assume that, okay, then create a rectangle, okay, and then one more rectangle, okay, and yes, and some other parts, assume, okay, then one more rectangle here, like this, great, okay, one more rectangle there, let me create, assume that I show the dimensions and fix the size. This is what, actually, this is assume that what I am doing, just as the sketch, drawing the boundaries of the development. Okay. Well, for this one, I'm going to apply trimming process, trim this, this, and that. Okay. And then finish the sketching stage, or just, well, trim this lines as well, sorry, trim this, this, and that, and this one, okay, finish. And then after the sketching stage, apply phase process, okay. Here I have a display problem, well, say I have say open loop, I think made a mistake at the trimming stage, so well, see the problem, and then well, clicked on this one, and then edit sheet option, turn back to sketching stage, and then try to correct the mistake, okay. Bring the cursor onto the sketch icon one more time, and then take the help of Sketch Doctor, right click, okay, and then Sketch Doctor, and then clicked on diagonalize sketch button, and then say okay, and then yes, Sketch Doctor saying that there is an open loop. Select this one and then see where is the open loop, here and there, okay. Another one, notice open loop, well, here and there. Okay, then clicked on next button and then say unhighlight problem. Try to use this tool. Okay, unhighlight and then say next. Okay, edit sketch, close loop. Okay, and then say finish and then say okay. Hope that well, I close the open loops thanks to the help of Sketch Doctor. Apply phase process. No, well, the problem still exists. Then okay, well, can do what? Next, and then select close loop option. Finish. Select a curve that is connected to the start and end of the open loop. Continue selecting curves until the loop is closed. Okay, this and the other, and then say okay. Yes, select this one. Okay, there are multiple sketch points where the highlighted curves connect. Okay, would you like to combine the points? Well, by mistake, well, couldn't understand, but had an open loop here and saying that close this open loop, saying yes. One more time say yes and then say okay. Yes. Is there any other open loop? Well, here and there Sketch Doctor highlighted that there is an open loop. Indicate this, indicate that one, and then it is also okay, I think. Finish sketching stage and then apply the phase process. Now it is okay. Thanks, guys. After having the model of the development unfolded form, then take a sketch right over the surface of this sheet metal work, and then in sketch mode, of course, say to be able to snap the terminal points, apply project geometry process for this edge, for this and that, and I think yes, one more, this edge, and then start line drawing process. Join this point to here, but say to be able to guarantee to have the terminal point precisely located along this boundary, I'm going to use trim technique. Well, it is a vertical line. Press escape button, changing the tilt angle, then try to make it say lighter in tone. Okay, start line drawing process and say that from here to there angle is 90 degrees. If couldn't perceive the angle, so created this boundary as inclined with such a further extension, then say that parallelism constraints say that this projected edge and this sketch are parallel. So well, you see I had this sketch line in the correct orientation. And what else? One more line is needed. These are just to mark in sketch mode the folding paths, the paths along which the folding process is to be applied. Okay, start the trimming process, trim this further extension, trim that further extension, and then finish the sketching stage. The rest, well, after marking the paths along the, let's say, over the surface along which the sheet metal is to be bended, apply fold process, folding process. Indicate this edge and then check whether the direction to fold is correct. If not, then flip flop 90 degrees bending and then say apply. And then, well, after creating this flange via which you see well, the sketch, although I already marked the other path lines on the same sketch plane, well, sketch has disappeared from the screen. Don't worry about it. Bring the cursor to the browser, clicked on this cross, and for this folding process I used a sketch. That is the corresponding icon. Right click the mouse and then ask it its visibility. After making the sketch visible, then you can find the other folding lines, folding paths, and then apply the folding process. Clicked on this and then indicate this edge, bending line, indicate this edge, okay, in which direction, that direction, and then say okay, apply, yes, or say that oops, undo. Well, apply folding process one more time, indicate this one. This means this is the main part going to be bended, holding this extension at its available position. Okay, flip-flop, this is to say that again in the up direction, not down but up direction, but while the main part is being kept stationary, this extension will be folded. Then say apply. Yes, you see this part is now folded. Well, here saying that fold this part, but impossible because, well, here in drawing the sketch, the bending allowance has not been considered. If I say that fold this part along this path, yes, although I am trying to indicate this path, but it is not distinguished because Inventor distinguished that there is no allowance over here. Then this sketch line is to be marked while considering the bending allowance at this half of it. So well, take a sketch right over the surface, new sketch, and then well, not starting from here, but well, a certain millimeters away, create a line in sketch mode. Well, say that I measure the bending allowance over the surface. Okay, distance from here, from this relief to this path is equal to, let's say, 3 millimeters. Okay, have the projection of this edge, and then trimming process to trim the further extensions. Finish the sketching stage and then similarly apply folding process. This is the folding line, and then see in which direction which part is to be kept. I'm going to keep which part, the main part, but fold this portion to have the flange in the up direction, and then say apply. Yes, and then finish the process. Well, since we marked some folding lines in sketch mode, although we had the sheet metal work, you see, well, I follow the different way. In case you have the development, okay, first have the flattened form of the sheet metal work, and then using which process, folding process, after having the paths of the bendings, paths for the bendings, applying folding process on the not flange but folding process, can have such flanges. Well, if you have such sketch lines in the screen, then well, bring the cursor onto sketch icon, right click and deselect its visibility. Yes, and then see the flattened form. Here it is, and then the rest is the same. Create the technical drawing, etc. Okay, dear students, this part is okay. Now here finally, as the third example classwork, I'm going to demonstrate how a loft as a sheet metal work is created. New file, sheet metal template, clicked on create button. Configuration, say that for the loft sheet metal thickness is not 0.5, clicked on this one, but say that 0.7 millimeters, and then say OK. The other things are all acceptable. And then loft process, start sketching stage. And then, well, in this example, loft is the adapter, okay, to connect a rectangular prismatic channel to a cylindrical channel pipe. Okay, it is necessary to have such a transition part. Well, in my lecture notes, I think can find my presentation in one of the slides on the page. There is such an example, photograph of such a loft. Try to find it. Yes, this folder. One more time, select this one. Nested folders I have. Orthographic projection folder, where it is, here it is. And then some details and exercises. Maybe this presentation, I am not so sure, but have a look at it. Yeah, yes, here is the slide. Say that we have such a channel air conditioning system. Well, one part of the channel is rectangular prismatic, the rest is cylindrical, and to be able to connect a rectangular prismatic channel to a cylindrical one, we need to have a loft adapter. These are just sheet metal works. Okay. See in Inventor how such a loft is created as sheet metal work. Okay. Since the cross section at the beginning of the loft, or in the other direction, if you see the loft, say that the ending cross section, it's not a matter whether it is starting or ending, but I know that it is a rectangular prism. Okay, well, the size from the inside surface to the outside surface, let's say, is how many millimeters? Say that the channel size is 1500 millimeters in this direction. The other direction, say that 1000 millimeters. And then the loft, the other cross section of the loft is circular in shape. So, well, although I know that there is a distance between the inlet cross section and exit cross section, there is a distance, but to be able to locate or position the exit cross section with respect to the inlet, well, in the same sketch mode, create both of the boundaries, the boundary at the inlet, boundary at the exit. And dimensional constraint, from here to the center of the exit cross section, distance is equal to, let's say, 500. From here to there, it is not 500, but say that 300. Why the centers of the centroids, says why the centroids of the cross sections are not in alignment? Assume that because of the existence of a certain say solid part, for instance a part of wall, we need to have such an offset. Okay. The diameter of the exit cross section, say that is 800. Okay, finish the sketching stage. And then, well, to be able to have this cross section at the corresponding correct level, need to use work plane. Clicked on offset from plane option, and then, well, as the reference, use the coordinate planes, expand the origin folder, and then, well, I see that not this but that one is just the plane, XY plane is the plane. Having the sketch plane, I had this sketches, so well, show this coordinate plane as the reference for what? For this offset plane. Well, here at that stage, as the offset distance between this reference and this work plane, considering the total length of the loft between the inlet and exit cross section, the distance, let's say, is 1800 millimeters in the example, and then say OK. And then after having the work plane at the correct level with respect to the inlet cross section, take a sketch right over this work plane, left click, right click, new sketch, and then, while applying projection process, have the copy of the circle on the surface of this work plane. Project geometry process, indicate this one, have this green line. Okay, it is the projection of this sketch. Okay, now you see, using this technique, managed to have the exit cross section with respect to the inlet at the correct place. And then, yes, the rest. Ready to apply loft process. Okay, here is the push button, loft flange. Clicked on this, and then, well, output. Well, in practice, we use two different technologies for creating a loft via bending the sheet metal. Well, by using little flat surfaces, or by using a specially designed die mold with a continuous surface, have the passing from flat surface to the adjacent flat surface. Well, after creating the loft, you're going to understand my sentence, what I mean. Well, first profile indication button is on, so indicate this to say that only the rectangle is the profile. Make a click, yes, along the edge of the rectangle. Do not indicate the circle. And then, well, second profile button is on. Indicate the second profile. Second profile not here, of course, but it is at this level. And then, can you see the simulation? Well, between this side surface to the adjacent side surface, we have, you see, since the geometry is changing from rectangle to circular, we need to have such a transition surface. Shall you have this transition surface between the flat side surfaces? Just using little flat surfaces, just folding this part of the sheet metal, okay, repeatedly using such pads in sequence, or just use an expensive template die. If you select this outputting option, then yes, this transition surface will be flat, a continuous surface. Well, if you're going to plastically deform the sheet to have such a curved surface, need to prepare expensive molds, expensive dies. Well, if the product is to be a cheap product, then use this option. Use flat, little flat surfaces. Okay, thanks to bending step by step, as a whole it is going to be as if a continuous curvy surface. Well, this is a cheaper solution and it is the common application. And then clicked on OK button. Yes, created the loft. And then yes, while this work plane can be hidden, take it as visibility, right click and deselect visibility option. And then see this transition part. Yes, inside is empty, it is a sheet metal work, it is a loft. Okay, but here from this flat surface, saying flat surface, what I mean, this flat surface to the adjacent flat surface, you see we have lots of flat surfaces. This flat surface, this flat surface, this flat surface. Although these are flat segments, since the sheet metal has been folded along this edge, along this edge, along this edge, using little bending angles, then to its appearance, well, as a group of flat surfaces, we have as if a continuous curvy surface here between them. Actually here this is the valuable question. Okay, these are the path lines, okay, to bend, to fold the sheet metal. Along this path, what should be the bending radius? What should be the folding angle? Actually, that question can be answered by an experienced technician in practice, but in this virtual environment, it can be answered by the software. Well, see how. First, after creating the loft, if you clicked on Create Flat Pattern button, you cannot see the development. Because, well, at present, well, the surface, side surface is continuous and closed. So, well, to be able to have the model of the unfolded form of this sheet metal work, and thereafter, via using this facility, go to folded path, and thereafter at the view creation stage to be able to have the flat form projection option, development option, well, need to cut this loft along a certain path over this surface, along this boundary, or along that boundary, or select this surface and along this path tear cut the sheet metal. Okay. Emboss, work feature, pattern, sheet metal, flat pattern, and then, well, have a cutting along the edge, this edge, and thereafter can go to, well, clicked on flat pattern, but here you see, well, the process to apply is rip process. Rip the sheet. Start the ripping process, clicking on rip button, and then, well, in this dialog, shall you cut the sheet along a certain path indicating single point? No, I'm going to indicate 2 points, point to point. I selected this option, and then, well, along this path, I selected this segment. I'm going to tear, rip the sheet metal. Okay, first rip surface. Here's the, I selected this flat surface to rip. with a click indicated. And then since I selected point to point, the first point is, why not this terminal point, and the second point is at the other end, this point. And after saying that from this point to that point cut the sheet, well, the gap size, how many millimeters? Say that gap size is into this box, write the gap size. Well, after the cutting, for instance, for having a welding gap, the distance is to be, for instance, 1 millimeter. And then say OK. And then wait, see the result. Yes, I selected this one. Can you see? Zoom in, zoom in. Now here it is not a continuous surface. There is a rip over here, cutting. Yes, after cutting the sheet metal, then yes, now I can ask the software to see the development. Go to flat pattern. Yes, here is the development. Unfolded form of the sheet metal work is in this shape. Okay, and then you see, for having the passing from this flat part to the next flat part, we have lots of flat segments, and this green line is just the paths along which the sheet metal is to be folded, is to be bended. Well, along which path, along which one, which path, in which order this sheet is to be bended. Actually, if you say that, okay, then start from here, first bend this, and then this, and then this, and then this, no, that is not correct. Okay, well, see, along which path, okay, this sheet is to be bended in which direction. Clicked on bend order annotation button, and then see, for instance, here make zoom in, zoom in, zoom in. Inventor saying that to be able to have the final form of the loft, then along this path first apply bending process. How many degrees? Using which bending radius? Can find the answer of this question, okay, on the technical drawing. After creating the development, it shows the object as unfolded. Then using the annotation tool of Inventor for this path, can learn what should be the bending radius, what should be the bending direction. Okay, but you see, this is important. First, apply the bending process along this path, and then along this path. But the preceding path, you see, is to be bended at the 67th stage. This is to be folded, the sheet is to be folded along this path at the 66th stage. You see, 1, 2, 3, 4, 5. Where is 6? Well, 6, well, for bending the sheet metal along the other edges. 6 may be here. But you see, after folding the sheet metal along this path, and then find the other path for which the bending order is 6th, and then turn back to it and fold the sheet metal along this path at the 7th stage, 8th stage, 9th stage. But this part of the sheet metal work is to be folded at the 66th stage. Yes, zoom out and then zoom in this part, and then see for this segment which path is to be used for folding in which order. 58th folding stage, 57th, 6th, 5th, 55, 54th, and so on. Yes, 40, and the others. Yes. Yeah, you see here such a strange figure is needed to draw over the surface of a sheet metal. And then after cutting the sheet metal in this shape, then the next stage is bending. Along those green paths, be able to bend the sheet. If you can correctly bend the sheet, then well, you can have such a loft. Okay, save this file in the memory. Classwork 1, 2, 3. Okay, say that surname, ID number, and then say that classwork 1, 2. This is the third. One model creation, and then view creation, second classwork. And then I said that if you had the development only by applying the folding process, then can create the model of sheet metal work. It became the third classwork, and this is the fourth classwork. Okay, classwork 4. Date of the creation is November 3, 3rd of November. And then for this loft, let us create the views. View creation stage, new file, ISO standards, first quadrant, and then well, the paper, I think since the loft is in the size of few meters, then well, I need to use a drawing scale, but first have the size of the paper as that of A0, and then start the view creation process. Well, define this side as it is front side. Scale factor, say that 1 to 4, no, 1 to 5, maybe more suitable, or 1 to 10, try. Why not? Okay, 1 to 10, because this projection will be the one to show the height in the final form of the object, of course, and it is maximum width. So under scale 1 to 10, well, can have the projections to show such dimensions. Top view, left side view, and then say OK. Folded model radio button is the correct button because the views are principal views, not development, not flat pattern view. OK. The valuable view is the development. Clicked on base view creation button for the developments, for creating the developments. Don't forget to click on flat pattern option. And then yes, well, I think it is going to be more suitable to orient the development like this. Scale factor maybe in this order, or use a greater size paper. Okay, and then dimensions. Well, the most valuable dimension, it is a technical note actually, along this path. Which order this along this path? The sheet metal, this development is to be folded in which direction, how many degrees? Yes, it is still a question, but after clicking on annotation tab and then bend button, and then if I indicate this folding line, then yes, can learn the answer. Inventor saying that observing the sheet metal in this direction along this path, fold the sheet metal 3.2 degrees. Bending radius is equal to sheet metal thickness 0.7. Okay, along this edge you see Inventor saying that bend it using 2.69 degrees. This is the folding angle. And then, well, show the annotations. Well, which one is to be folded first, in which order? Chamfer, fold and thread, dimension. Well, of course, first configure the dimensioning facility, manage, styles editor. Okay, for instance, this precision is wrong, 0.70. Well, decrease the precision to 0 for the angles as well. Display option, at the beginning of extension lines have space, 2-3 millimeters. Text, select Arial as the style, etc. And then nodes and leader lines to have horizontal tail. Clicked on save, save and close. Now say 3 degrees, 3 degrees. Decrease the precision. Annotation, hole and thread, bend, punch, chamfer. Retrieve model annotations. Clicked on this button. Okay. Well, if you have a 3D annotation, then yes, clicking on this, you can have the dimensions. You show some dimensions using 3D annotation tool of Inventor. So, while clicking on this button, you can automatically have the annotations. Okay, that is the tool. And what else? Balloons. It is not an assembly, so it is not the option to select. Insert sketch symbols. Clicked on this button and then say local symbol library. If you have some symbols to show, then you can indicate and say that show them. What else here? These are about surface texture symbols, welding symbols, and geometrical tolerances. Later you're going to study on such things. Okay. Well, if you show the bending angles and rounding radius, bending radius ready for each of the folding lines, folding paths, then the text may coincide onto each other. So, well, to be able to prevent clash between the written text, okay, well, show this one. Clicked on this button and then show this one, show that one. You see, show this one, the text just overlapping, clashing. Well, if it is the case, then what you can do, press escape button and then, well, hold this annotation, say technical note from its gripping point and then drag the mouse. You see now here I'm using leader line technique. Hold this one and from the green gripping point and then have this leader line. Yes, using such a technique, then you can make the text as distinguishable, readable. Okay, there will be no clash. And the dimensions, of course, show this dimension. Clicked on this one and then indicate this and then show this dimension. Yes. Well, this is the development, and technician using this dimensions can draw this figure. This dimension. Say okay. This dimension, and of course the other dimension is the angle. For instance, with respect to this edge, what is the inclination for this one? Show this angle, 18 degrees. Okay, with respect to this edge, what is the angle for the other boundary? show this dimension. Okay, angle, how many degrees? 148 degrees. And for this one, you know, this is a curve. Actually, for this curve we have, since flat segments, then one by one need to show their dimensions, or just well, for the points to mark, this point, that point, well, be able to show the coordinates relative to a certain reference. For instance, well, relative to this corner, what is the coordinate of this point to mark? Here it is, the answer. With respect to this reference, well, show this location dimension to guide the technician that this folding line is to be marked using this coordinate value. Actually, here, if you select ordinate dimensioning option or baseline dimensioning option, then yes, show this, show that, show the other, etc. And then right click the mouse, continue, and then yes, you can have the coordinates for each of the indicated path lines, folding lines. Okay, the coordinate in the vertical direction, coordinate in the horizontal direction. Yes, show these dimensions. Well, of course, for showing all the location dimensions and all the technical notes, these are about the folding angle and direction. This is to say down direction, fold the sheet metal. Then you may need to use a bigger paper, greater drawing scale. Okay, and show the other dimensions and be able to complete this exercise. I'm going to, since there is no new thing, okay, additional to inform you, I'm going to stop here. But in solid model environment, yes, you can, after having the flat form of the sheet metal work, and then clicked on show annotation, bending order annotation, can see this info, which path is to be used at which stage in which order, okay, to fold the sheet metal. Folding angles can be seen from the technical drawing. This is the path along which the sheet metal is to be folded 3 degrees, but the next one, along the next path, sheet metal is to be bended 6 degrees relative to the preceding one. Yes. The rest, of course, depends on your interest. At home, you may continue on the rest and complete. Show these dimensions. Well, on the front view, what is the maximum width of the sheet metal? Here it is, work. Okay, and the height of the object from here to there, show the height. Okay, and the maximum depth of the object from this outer boundary to this reversal of direction point is the distance, overall depth of the body. Okay. No need to show the location dimensions. No need to show the diameter of this edge, because, well, if the development is in this shape and in that size, and if the sheet metal is folded along such paths using the bending angles correctly and the bending radius, then you can sure about it that in the end you're going to have such an object. Here it is, the model. Well, along the edge, well, there is a rip. Well, find where is the segment along its edge we cut the sheet metal. Zoom in, and I am sure one of them there is such a cutting. Couldn't find it. And then, well, to say, after studying the weldments on the weldments, then well, can say that the rest. Say, to be able to create the development, yes, cut the sheet metal, have had a rip. But after the folding stage in practice, well, it is to be closed. How? If it were made of cardboard, then I would say that have furtherly extended parts and then using a glue, paste the glue and then paste it, connected. But in practice, if it is made of sheet metal, if it is made of steel, then yes, apply welding process. Click on environment button and then convert the model to a weldment. Okay, convert it to a weldment. First standard part, and then, well, apply the welding process. Later you can see how. First study one time on the weldments and then can understand the rest. But here say that, well, along one segment, such little flat surfaces, there is a rip. Okay, rip. Well, still looking for, but zoom in, and then can see where is the rip. Or just clicked on go to flat pattern, and then yes, the rip is along this edge. Since the gap is very little in size, yeah, well, finally I found it. Here is the rip. Can you see? 1 millimeter space from here to there. Well, applying welding process, then connect this edge to the other. Applying welding process. You're going to see how it is applied later. Okay, my dear students, I finished this classwork. So, well, clicked on this button to allow you to see my face, and then shake the hand, say bye bye. Stop the recording.